This is the last video in CC2 and it is about potable water. So potable water is just water that is drinkable. That doesn't mean that the water is pure. Okay, the water that you get from your taps, the water that you find in plastic water bottles, it's not pure water. There are minerals dissolved in that water, therefore it is not pure, but it is drinkable. Potable just means drinkable. And in terms of creating potable water, there are a number of processes that need to be followed. So first of all, it's worth noting that most of Earth's water is seawater. Because it's seawater, you've got a high salt content and it is not safe to drink. So the first thing we could ask ourselves is, well, how can I separate the salt from the water but keep the water? It's something that we covered earlier on in this topic, and the answer is distillation. Okay, so crystallization would allow you to obtain the salt, but you'd lose the water. If you want to keep the water, you're going to use distillation. So I've got the apparatus set up here. I put my salt water in my round bottom flask and I heat it. The water, once it's heated, will evaporate. The hot vapors will rise. Then they hit the condenser, where the water vapor is cooled. It's condensed back to a liquid, and that liquid can be collected. In order to keep my condenser cold, I surround it with water from the tap. The water goes in at the bottom, the water comes out at the top. So I can use this process of distillation to separate salt from water. The salt remains in the round bottom flask and I collect pure water, which would then be potable. I would be able to drink that water. However, this process, if you were going to carry it out en masse, to provide your drinking water for millions and millions of people, this process would be way too expensive. Okay, it involves heating the water to generate the energy needed to heat huge quantities of water. That would be very, very expensive. So this process is not going to be used to produce drinking water. This process is used to produce pure water for chemical analysis. So if you're doing any kind of analysis tests in a lab, you would need to use pure water, as any ions or salts dissolved in water could interfere with your results. But in terms of drinking water, there are other ways to produce drinking water that are far cheaper than trying to distill en masse. And I'm just going to put this book underneath here. This represents a typical process for purifying water. And the water that you're going to purify for drinking water is not going to come from the sea because of the high salt content. Instead, you're going to get drinking water from rivers or lakes. Now the water in rivers and lakes, they mightn't have a high salt content like seawater, but they're definitely not safe to drink. You might have leaves, twigs, grit, salt, bacteria, microorganisms, lots of stuff in rivers and lakes that make them unsafe to drink, even though they don't have the same high salt content. So what you will do is you'll take the water from rivers and lakes and you need to treat them to make them potable. You're not purifying it completely, you're not going to end up with pure water, but you're just going to end up with water that is safe to drink. So there's a number of different processes that water will go through. Depending on what source you're looking at, you might find these processes in a slightly different order, but in general, they're going to go through two main processes: sedimentation and filtration first. So sedimentation is when you add the water to a large tank and you just leave it there. And what will happen is all of the solids, the insoluble solids, will just settle to the bottom of the tank. So you just leave the water sitting there, all of those solids will just fall to the bottom, and then you'll be left with your water at the top. You're then also going to filter that water, and you can use different substances to filter the water. So gravel is much bigger and it will take out large solids, but sand, the space between sand grains is quite small, and that will filter out smaller solids. So sedimentation, you just leave the water to settle, solids will fall to the bottom. Filtration, you pass them through some form of filter, and again, the insoluble solids will be filtered out. A lot of soluble solids will remain, okay, that you're going to have salts and ions in there that will remain in your drinking water, but that still means that it is safe to drink. But what you do want to get rid of from your drinking water is any bacteria or microorganisms that could make you sick. So you add chlorine to your water in order to kill bacteria. So chlorine acts as a disinfectant, it will kill the microorganisms, it will kill the bacteria and make the water potable. It will make the water safe to drink. So I've got a few sample questions here. Why do you add chlorine? That's a really common question, just to kill microorganisms. Fluorine can also be added. Fluorine's really good for your teeth. So they sometimes add fluorine to drinking water just to improve dental hygiene. Describe how water from a river can be made potable. So remember, potable is just drinkable. It doesn't mean pure. You don't have to remove everything from water. You just have to remove the harmful substances. So you can filter it and you hold it in sedimentation tanks. So they're the two things that you definitely need to be mentioning. Filtering to remove large solids. You hold it in a tank and that will let smaller solids settle to the bottom. You then, filter it again, as long as you're mentioning filtering once and sedimentation once, and then you're also going to be talking about chlorine, adding chlorine to the water, and then say why you add it. So there's three main things you need to talk about: filtration, sedimentation, and chlorine, and talk about why you go through each of these processes. Groundwater is purified. So by groundwater, I mean water from rivers and lakes, as opposed to seawater. Why? And the reason seawater has a really high salt content, the only way to get rid of all of that salt would be to use distillation, like we discussed at the start. Distilling that quantity of seawater would require a lot of heat energy and would be expensive. So it's just not practical to distill a huge quantity of water. However, you are going to distill water if you want to use it for chemical analysis. You have to get rid of all of those salts because the salts would interfere with your results. So chemical analysis, if you're using water in a laboratory setting to run chemical tests, you would need it to be pure water, so that water is distilled. Just got one exam question here. Which type of water is potable water? So which type is drinkable? Do you drink water from the tap, the sea, wastewater, or groundwater? So groundwater would be from rivers and lakes, and the answer is going to be the tap. Okay, tap water is drinkable. If you distill seawater, you get a white solid and a colourless liquid. What are they? The white solid you would obtain from seawater would be salt. Seawater contains salt, and the liquid you would obtain would be water. So if you're distilling seawater, you're separating the salt and the water. The salt is the white solid, the water is the colourless liquid. This is quite a niche topic. However, it's really, really simple. So please don't overlook it. Make sure you can describe how you would purify groundwater, know why chlorine's added, know why fluorine is added, and know what potable means. It's easy content, and again, something you should be targeting full marks on.